have you heard the story about the guy who put null as his license plate in California?
No. Did it
So
cause trouble?
his thinking was, oh, well, I'm going to put null on it. And if I get a speeding ticket, it's just maybe I'll get lucky and it'll be null in the database and it just won't get associated with me. Turned out the opposite was true. He got like arrested, I think, because he had like $12,000 worth of unpaid fines associated with him, because anytime there was an error in the database, it would just like tag it to his license plate number, which was null, which I thought was amazing side effects.
That's funny. Hey there, welcome to Book Overflow. This is the podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here, as always, by my co-host, Nathan Toops. How are you doing, Nathan?
Hey, everybody. Doing great.
Well, thanks, everyone, for tuning in. As always, if you're on YouTube, like, comment, subscribe. If you're on an audio platform, leave us a 5-star review. Share the podcast with your friends and coworkers. It helps it grow. And we appreciate you for being a listener. And to our regular listeners, we were off last week. Nathan and I were both traveling for work. I was in the beautiful city of Austin, Texas, which I'd never been to before. Lots of fun. Where were you at again, Nathan?
I was in Nashville, Tennessee, also another city I've never been to before.
There we go. Central Time offsites. We have recorded an offsites before, but we were just both off and thought, let's give ourselves a break. So you can check out our interview with Pramod Sadalage, which we released on Monday instead of our usual Thursday bonus episodes. Super great talking with Pramod. Big database guy. That's something I'm not super well versed in. So I thought it was a ton of fun to get his take. He's really a database expert.
Yeah, I agree. It's also interesting. He's fighting the good fight as far as taking a lot of these concepts that we've had with evolutionary architecture, software architecture, and software engineering best practices, and trying to get them into the data engineering and data world. And it's interesting, while we're adjacent to each other on teams all the time, what has translated into best practices and I should say, what did Martin Fowler call them? He called them sensible defaults, right? Is
Yes.
a better term than best practices. Yeah, it's cool, and I highly recommend it, especially if it takes you out of your comfort zone. I think Carter and I both are a good proxy for, let's talk to somebody who's an expert in something, and we're a little out of our comfort zone. So,
yeah, great interview. Check it out. And again, for our regular listeners, we had talked at the end of the last discussion episode about how we'd be covering the Software Engineer's Guidebook by Gurjli Oraz. I need to learn how to pronounce that name. And we still will be covering that book, but just because we took a week off, our schedule got a little jumbled. So instead, we needed to find kind of a short book to tackle just to fill 1 week. And we found a great one, which is Tidy First, a personal exercise in empirical software design by none other than the Kent Beck. Now, Kent Beck, you'll remember his name. He is a contributor to Refactoring by Martin Fowler. He's one of the signers of the Agile Manifesto. Really one of the kind of the titans in the industry. This is the official author introduction we get from him. It says, Kent Beck is the founder and director of Three Rivers Institute. His career has combined the practice of software development with reflection, innovation, and communication. His contributions to software development include Patterns for Software, the rediscovery of test-first programming, the XUnit family of developer testing tools, and extreme programming. He currently divides his time between writing, programming, and coaching. Beck is the author/co-author of Implementation Patterns, Extreme Programming Explained, Embrace Change Second Edition, contributing to Eclipse, Test-Driven Development, by example, Planning Extreme Programming, Smalltalk Best Practices, and the JUnit Pocket Guide. He receives his BS and MS in Computer Science from the University of Oregon, which, if you are following, are the #1 team in college football right now. So Kent's probably pretty proud. BYU is number 9, so we're all happy here in Utah.
And I'm completely ignorant about all things football. So
I used to just be like it was actually one of my first jobs in college. Was I got a job selling football tickets, and we'd like call people who bought like single game tickets and then try to upsell them to season tickets. So I know anything about football, but I liked sales, so I got that job. That made me kind of a BYU football fan. And then when we moved back to Utah, I got season tickets. So we've been doing that, and then I just followed college football in general.
That's cool. That's fun.
Yeah. It's fun. So I hope Kent Beck's enjoying that his Ducks are crushing it in football this year. So what is this book about? The book introduction we get is messy code is a nuisance. Tidying code to make it more readable requires breaking it up into manageable sections. In this practical guide, author Kent Beck, creator of extreme programming and pioneer of software patterns, suggests when and where you might apply tidyings to improve your code while keeping the overall structure of the system in mind. Instead of trying to master tidying all at once, this book lets you try out a few examples that make sense for your problem. If you have a big function containing many lines of code, you'll learn how to logically divide it into smaller chunks. Along the way, you'll learn the theory behind software design, coupling, cohesion, discounted cash flows, and optionality. Now, I think it's funny that it kind of throws in there along the way, you'll learn the theory, and it lists out a couple of things. It's a huge chunk of the book, this theory of coupling, cohesion, discounted cash flows, optionality. I thought it was the most fascinating part of the book. This book is about tidying software. There's obviously naturally a lot of overlap with Refactoring by Martin Fowler, which obviously Kent Beck was a contributor on. But the stuff about kind of the theory of software development, like the monetary theory of software development, I found really fascinating. And so, in my opinion, I think the book kind of morphs into a very different book in the back half. And in my opinion, not that the first half isn't useful, but I've seen a lot of that. And like having read Refactoring, there were parts of it that felt like a bit of a repeat. The second half were a bunch of new concepts. I think I could kind of, like, of course I know about like, net present value and all that, but seeing it applied directly in a software context was really fascinating. What about you, Nathan? What are your thoughts on the book in general?
Agreed. Yeah, it's cool that when we look at each other's notes for the episode, it's neat to see what resonates, and sometimes they resonate identically, and sometimes it helps with shoring up, blind spots that one of us had. But I think this was the most engaging part, and it was interesting, yeah, because it's like deep in section 3 or part 3 of the book. I loved this book. It's very short, gets to the point. The chapters are like little mini chapters. It's like these, very focused thoughts. It reminded me a lot of the practice of programming, in that there's this sort of like encapsulated little nugget of wisdom. Though with a different worldview, right? This is from the TDD world. This is from the world of deep into the object-oriented programming. And it's really cool to see how those ideas from extreme programming and others have evolved over time and what hasn't changed. Again, I think my notes basically say it's practical, pragmatic, and concise. The first 2 sections of the book are very like straightforward as far as implementation details and examples of like how to recognize these patterns. And then part 3 just gets into super like philosophical area, which it was a surprise and delight section. And I also thought it was cool. The book's actually not called Tidy First. It's Tidy First. There's like a question mark. And I didn't realize how important that question mark was until I got pretty far into the book, because this really is about identifying, should I tidy this first, right? This is this sort of compulsion that all of us can get of, okay, this is messy. I need to just clean this up and then I should do it. And he actually gives you a really nice set of tools to say, is that true? Like, why do I need to tidy this up? And what method of tidying should I do? And is it valuable to the business, and all these other kind of cool questions that you should ask yourself, especially as you move up in seniority as a software engineer. Because I think, and one of the things they don't mention explicitly in the book, but I think is very valuable here is, I know folks who are tidy obsessed, and they can lose credibility if it gets in the way of like sort of the business value, the maintainability value, just because they might have an opinion on how the shape of the code should be. And I think this gives you a bunch of tools to back up why it's worth doing some piece. I also like that, and we'll get into this, right? It is a compliment to refactoring, and he actually calls this out explicitly in the preface. He calls this a subset of refactoring, right? Like that tidying are these like cute little things that you can do. But I think they're incredibly powerful, and I think it makes a compelling case as to why you should make time to tidy.
Yeah, absolutely. And we're gonna get into more detailed discussion of the book, but one thing I love about reading books like this and just the podcast in general, because we're reading so much, is I feel like I'm kind of accelerating my career and moving past, like, I think I'm moving past phases of my career that would last too long if it weren't for reading these books. And what do I mean by that? I mean that, like, right now I think I'm in my prime, like, Yagni phase. Like, you aren't gonna need it, because I can tell, like, just where I'm at right now. I want to say, oh, we're going to future proof it. We're going to make it so flexible and extensible, and it's going to be beautiful, and we need to tidy because this is our craft and we take pride in it. And you read these books by people like Kent Beck, who have been doing this a long time and pioneer that concept of Yagni, right? And it's just nice for me because I'm able to see people who have been doing this a lot longer than I have and say, oh, wait a minute. So they all went through that phase too, but they came to the conclusion that that's not the right attitude to have, right?
Right.
And so I think, again, reading books is, I think, a bit of a cheat code to kind of leveling up your career. So I've appreciated reading this book and just reading books in general. We're going to talk about this book in particular. It's divided into 3 parts. We're going to address them roughly in order, but we're also going to kind of jump around because this book has a lot of great stuff. So we'll be back with all that and more after a quick break. And we are back. Thank you for tuning in. Well, let's talk about this book. It's divided into 3 parts, and they kind of start out more specific and then get more theoretical as it goes on. So part 1 is tidyings. This is kind of like the back half of refactoring, which is the big kind of refactoring catalog and all the different kinds of refactorings you can do. Kent Beck starts with that, moves on to part 2, managing. How do you fit tidying into kind of a personal development workflow? And then part 3, which is the theory of tidying and the business theory of why it becomes valuable. So I guess up top, when we talk about tidying, Nathan, you had mentioned this was a subset of refactorings. What does he mean by that exactly?
Right. So, I think refactoring has kind of gotten a bad rep. So the quote that I highlighted in the book was, tidyings are a subset of refactoring. Tidyings are the cute, fuzzy little refactorings that nobody could possibly hate on. And then he also goes on to say, refactoring took fatal damage when folks started using it to revert to long pauses in feature development. And so I think this is one of those areas where refactoring has kind of become this messy, ill-defined word of going back and like retooling and redoing. And we've actually learned, right, that we have overloaded this term, that refactoring really should have no external side effects. It's like the real definition of refactoring. And then, going back and restructuring your code or doing these other things that actually do change the system aren't technically refactoring, but we live in this world and people call that refactoring, right? It's like this idea that we should freeze feature development. We talked about this in Unicorn Project, right? The feature freeze where they go back and like fix a bunch of stuff. And that mostly can't work. A lot of times the businesses can't do it. And so I think it's really cool for him to unburden this overloaded term with like, oh, no, I'm not refactoring. I'm just tidying, right? I'm gonna do these things which are refactoring tasks, but they're things that can be done on these like really short life cycles, which again, and he gives you a framework for it. I get the beginning of the book literally goes through a bunch of stuff. I think it's 16 or so chapters in the first section, maybe 15 chapters in the first section. And I don't know, there's lots of examples. I've highlighted stuff. I'd be happy to hear your thoughts on this tidying versus refactoring debate he's making.
It's interesting. I'm a big death of the author guy, where I don't love when you've read a book and you're discussing what it means or your take on it, and someone will say, well, the author meant it to mean that. I'm like, that's great. The author can mean whatever they want to,
Right.
But I'm talking about what's in the book. I remember in high school, we did this, we had to like write poems for some reason. And in like one of our AP Lit classes, I think, and this one girl in my class wrote this beautiful poem about kind of like, why do we jump just to fall back to the earth? And it was kind of like this like somber take on like, is it worth even expending effort? And so we spent like, the class stopped dead in its tracks to talk for like 15 minutes about what this poem means. And then at some point someone said like, wait a minute, the author is in class with us. let's just ask her what it means. And she's like, to be honest, she's like, I wrote this poem when I was sad because my dad got rid of our trampoline. And so
No
like,
way.
yeah, exactly. Right. But it was one of those things where it's like, I think she wound up writing something much deeper than what she actually set out to write. And I kind of feel that way with like the term refactoring, which is, I think Martin Fowler would be disheartened to know that, like, that's what I thought refactoring meant when I started out. Like, again, this is you pause feature development, you completely rework the code, it enters a broken state for a period of time, and that's why refactoring gets a bad rap. So I think it's interesting that we have this kind of like semantic stretch where now we have to say, okay, well, no, tidying isn't refactoring, even though refactoring in its purest form. But I think at a certain point you lose the battle for definitions. That's the author. Who cares what? I know Martin Fowler didn't invent the term refactoring, but I think he's easily its largest proponent.
Yeah, popularized it in the
absolutely. So yeah, as far as these tidyings go, I mean, they're pretty simple. Like, you're going to read through this section and be like, yeah, like, I get that. It's not like refactoring, which kind of is a little more strategic in nature and detailed. I mean, some of them are like dead code. He says, delete it. That's all. If the code doesn't get executed, just delete it. It talks about reading order. It says, reorder the code so the elements you need to change are adjacent. Cohesion order says, reorder the code so the elements you need to change are adjacent again. But that can just even be things like, sometimes you'll see an element like you'll see a variable defined, but then it's not initialized until after 7 lines of code or so. He's like, if there's not a reason for that, just move that.
I liked that. The cohesion order thing's cool because cohesion is actually a pretty abstract thing he brings up later in the book too. And he'll put these little algorithms in there that I actually like appreciated. They're kind of cutesy, but they're also kind of like awesome. So he'll be like, well, should I do this? Like, should I mess with the cohesion order? And he has this little one. It's like, well, the cost of decoupling plus the cost of change. If it's less than the cost of coupling plus the cost of change, then you should change the cohesion order, right? So this idea that like there's and I think the framing helps a lot. Like, so he doesn't bring up these core ideas till later in the book, and I think we'll take a little side quest real quick. He starts framing. He gives you all these tidying things, which is like, here's the things you can go do. Like, and again, it's like, oh, my desk is messy. Okay, well, first take all the papers and stack them up in one place. Now go through your papers. Are these memories? Are these important notes? Do I need to move them into something? Right? It's like these like tactical pieces. But for me, it's like, I want to know that, oh, well, people who have clean desks are 50% more likely to get all their tasks done for the week, right? Like, that's like the why of like why you should clean your desk up. Those are helpful. And I actually need those whys before I hear the tactical tidying pieces. And I think refactoring would do this in little spurts, right? It would say, here's the thing, here's the pattern, here's the anti-pattern, and here's why you should do it in these little chunks. This book kind of takes a larger thing of like front-loading tactics, front-loading how you fit those tactics into your routine, the management part, and then the big why. And so I think as we go through this, he ends up putting all of these in these questions that you should ask yourself of, should I do this tidying task now? Or should I do this tidying task later? And the 4 main areas he brings up are cost, which is, will the tidying make costs smaller or less likely? Revenue, will the tidyings make revenue larger or sooner or more likely, right? And I like that this is framed in the sense of like, am I being valuable to the business that I work for? We know that this is a valuable mindset that we saw in Unicorn Project. Coupling, right? Which again, overloaded term, and I think we're always in this dance of coupling. But the idea is, will this make it so that I can change fewer elements in the future? And I think coupling is a really powerful idea because, if you remove coupling, it makes it easier to actually do tidying in the future, right? So there's these like feedback loop that happens, and then of course cohesion is, will tidying make it so that elements I need to change are in a smaller, more concise scope. And so those are the 4 like big takeaways. And if you look at any of these, like removing dead code or extracting out helper functions or these other things that he'll bring up, they're all in the lens of these things later. I see this now going back, right? I think if I had only started reading the book and I started reading tidying section and I didn't get through the whole thing, I think I would have missed it. I'm really glad we're going over this as a podcast because after reading the end, I was like more excited to go back and explore what we read in the beginning.
Yeah, he lays out in the beginning, and he kind of has the opposite approach where he says that he needs to understand like what the concept actually looks like in practice before you can appreciate the theory. I'm a little the opposite. Like I appreciate getting a bit of the theory up front before getting into the exact details of this. But also, it's like we said, like we read a ton, and we've already read Refactoring, and so reading kind of the first part of this, you think, is this just going to be a rehash of Refactoring, but like micro refactorings? But I think someone who had never been exposed to the idea of tidying or refactoring would
Right.
would find it more interesting. He had some tidyings which I found not like controversial is way too dramatic a word, but which I maybe disagreed with, and I know other people might disagree with too. One is explaining constants. So this is actually something I've been thinking about just a bit. We talk about the idea of magic numbers, right, in coding. Like you shouldn't just say like, then divide the result by 7. It's like why 7? Why are we dividing by 7? You need to know what that means. That I'm all on board with, right? But I just thought it was interesting that the example he gave, and maybe it's just because he needs an example. He said, like, don't return like just a 404 code, right? Just 404.
Right.
Make index that to a constant, page not found, and then return that. That was an example to me where I was just a little like, I don't know. I think we all know what 404 means in a web context.
Well, so this was one that I liked, and I also have a good counterexample for. So from an implementation standpoint, so his argument was right, yeah, and I think Python does a pretty good example of this, which is like they've made constants for all of the human readable constants for all of the error codes. And so when you're reading over the code, it's very nice for folks who maybe don't have the HTTP codes memorized. And I think if you work with HTTP for a while, you probably know most of them. But there's a bunch, and sometimes people will get into these weird 500 errors that you've never seen before, or some 400 errors that are a little higher up. And for the uninitiated, there's all these like standard status codes. 200 is like 200 okay is like the thing when you get a response and it's the acceptable one. There's 300s are these types of redirects. 400s are there's some sort of issue, but the code's functioning properly. And then 500 is there's a server problem, internal server problems that are happening. There's a lot of these are conventions. You can omit 500s on a successful response if you wanted to. Don't do that. But I think that the code is more readable if you're not in the secret, terse language of knowing what these error codes are. I will say a good counterexample. We actually were implementing a circuit breaker pattern at my previous company, and there was an error status code that was not included in the enums for C#. So like C# had an enum of all the constants of all these error codes, but apparently either it was a very old version of the library or it was a less common thing. They never enumerated it. And because it was a statically typed language, it required an enum in the function signature. And so it was a good example of like, it broke the stuff. Like there was no way for us to do an override. We actually had to like come up with some really weird twisty way of like making this work, and it actually made things worse, right? Like in that case it would have been nice if it was like an actual constant where it would have been nice to have a human readable thing, but I could have put in a number that maybe didn't mean something or define my own. So I think that was like it jumped out to me because I was like, somebody built this to be more empathetic and actually made my life worse.
There's someone in my part of the city, I've seen them drive around with the vanity license plate HTTP 200, and I am so mad that I didn't think of that first, because that is an awesome license plate.
Breaking off, have you heard the story about the guy who put null as his license plate in
Oh no.
California.
Did it
So
cause trouble?
his thinking was, oh, well, I'm going to put null on it. And if I get a speeding ticket, it's just maybe I'll get lucky and it'll be null in the database and it just won't get associated with me. Turned out the opposite was true. He got like arrested, I think, because he had like $12,000 worth of unpaid fines associated with him, because anytime there was an error in the database, it would just like tag it to his license plate number, which was null, which I thought was amazing side effect.
That's funny. I'm gonna have to ask ChatGPT today and say what's a good vanity license plate for that has to do with programming, because I saw HTTP 200. I'm like, I need it.
I bet you could do Book Overflow and just drop some vowels or something.
Yeah, maybe right. But then I'll look pretentious, and if this podcast doesn't become a huge thing, then
the Hall of Shame. Yeah.
Yeah, exactly. Yeah, I also feel like, I don't know, what is the idea of constants? Like, to me, this feels a little language dependent. Like, I definitely see more kind of like magic numbery stuff in like Python.
Mhm.
But I also guess it kind of depends on the scope of the project. I use Python almost exclusively for utility scripts or like little lambdas. I've never written like a big Python API, so I can see it, wanting to define your constants a little more there. It's funny, one of the classes I'm working through on my master's degree, it's not my favorite class in the world because it's like basically like the master's version of like intro to software development,
Right.
and it's all in Java, which I know Java, fairly well, but it's more a game of like figure out what the instructions are asking for, and less like less like actual software development. Like I forgot to turn in like a weekly report. I'm like, sorry, we can't accept that. I was just talking with the TA. I'm like, I am a staff engineer. How is this class giving me so much grief? But anyhow, we were doing a group project, and naturally, most people who take the class are not like me. I had to take it just to fill kind of like a requirement. A lot of people are actually people who are coming in and new to software engineering, and
right.
And a lot of them, their only experience is Python, and we had to write like an Android app together. And it's just funny watching some of the Java these guys wrote. I'm like, this is not Java. Like this is Python pretending to be Java. And it's weird. It's like, why do we use getters and setters in Java? Right? I know that there's it's the idea behind that is that then you can add additional like validation logic or any other logic when you access these variables. 99% of the time, people don't do that. It's just like another layer that returns the variable directly. I don't know why we don't do it in Java, or why we don't allow just direct access to the variable in Java. Everything's through a getter and setter, but we do. And it's just funny looking at the code people had written, because they hadn't done stuff like that, and just some other funny little examples. But yeah, all that to say, with this idea of explaining constants, like it depends on the scope of what you're writing. It depends on what language you're writing in. Even in Java, even if you were writing something very small, it would be very strange not to explain a constant. Java is just a very verbose language. That's something I would flag in a Java code review, not necessarily a Python code review.
Yeah. Yeah, I'm a fan, and it's pretty common, especially in like cryptography libraries, which I've been spending a lot more time in recently. It's my new gig. Like in Go, I would say it's like, especially if your language supports the idea of a constant, right? You define something once and it can't be redefined. It's really nice to be able to pass those around, especially when you're talking about like byte lengths and all these other things that if you get it wrong, it's devastating. Like it could actually be, it's a security nightmare. And so you don't think of like 32 bytes, you just think of like, key length or, some abstract, term on top of it. And so, in the future, if it goes to 64 bytes, it's okay. Your code's fine. It says, key length or whatever, is what it is. So, yeah, I thought that one was interesting. I think if you do it as true constants, where you're literally just putting a meaningful syntax on top of a value, like a primitive value, like a number, I think it's great. I think enums, which, Go doesn't actually have the concept of enums, which is, a lot of people who love enums get really all upset that Go doesn't. But the nice thing is that Go, like, it's really just constants that get an iterator. Like we don't have real enums, but what the nice thing is you can define something that's not part of your enum. My only problem with enums and union types and stuff like this is that sometimes you need to operate outside of the constraints that are in the enumerated lists, and you get into problems. And so, yeah, that's the only thing. But that's like a type theory problem, and not a when should I do tidying. Obviously, if your language doesn't support certain things or it has other constraints, you shouldn't do it. So there's a couple other things that are in this section. Again, he brings up a ton of topics. We're just kind of touching on ones that kind of hit us. One where I had mixed feelings about was extract helpers. So this one's interesting. He kind of says, like, you have this longer function, you have this stuff that will never change in this section of it, you have the stuff that'll never change, but you have this section that you kind of want to tidy up a little bit. And he actually recommends yanking that out and putting it into a helper function. I disagree with this in principle, unless you really do think that that piece of code would be useful elsewhere. And I don't mean that you change the external. A perfect example of this is I recently wrote a little library of like a little tool I was building, and I needed to verify the correctness of like some hashing algorithm. I ripped out the verify logic because I realized there was like 2 or 3 places that I needed the exact logic, right? So that is a good example of I could have inlined it, but I would actually have 3 implementations of verify. And it was not that many lines of code. It's like probably 5 or 6 lines of code. But there was no benefit to it being inlined. It would make more sense for me to just go, you know what? I'm going to use the verify. And I still kept it as a private function. So no consumer of my application ever can use it. It's just an internal state thing. Like if I create a new version of this thing, verify it's correct. If I, pull it from bytes or something, make sure that's correct. But so I think there's a nuance to this that he doesn't really bring up. It's kind of he just gives the helper of like, oh, if you want to obviously change this one section, yank it out into a helper. And I think that can be counterproductive, because if you go back 6 months from now and something was inlined and now you have to go and like, you see that there's this function call and you have to go and look into another part of your code to see why it breaks up your flow when you don't need it. Verify is a good example of like, it completely meaningful. I know I can go look and see what verify is one time. And then if I see verify called 3 different places in my code, there you go. It's not that complex. But this is one of those, like, it made me think of John Ousterhout and the tactical programming piece where you're like, you start getting to the line count stuff. And I think someone could misinterpret extracting helper functions where they kind of like explode out a function that actually makes total sense for it to be completely inlined, and breaks it up into these tiny little functions that you're like, what is happening? What is happening right now?
Yeah, he talks about another kind of tidying. He calls it one pile.
Right, which is the counterexample to this, right?
Exactly. He says the biggest cost of code is the cost of reading and understanding it, not the cost of writing it. And he says, and this is much more in line with like John Ousterhout's take on functions, which is, maybe it makes sense just to have everything in one big pile, because that's where the effort comes, is from reading and understanding the code. And if you have to constantly be clicking into and digging, every function is just a call, 4 lines of calls to other sub functions, and you have to dig 3 layers deep to actually get to what the code is doing. It's it increases increases that cognitive load. I'm leaning more towards the Ousterhout way. I think sometimes you can write a function that is just so clear, like where the details of it actually don't matter as much as maybe the rest of what the code is doing, that you can kind of extract it out to its helper function, and then as you abstract it away from the reader, you're kind of telling them like, hey, don't worry about this, right? Like that's not the meat of what's going on in this code. And so they can click into it if they want to, but you can imagine a scenario where, you're going through and then it's like find largest order number, right? And like me, as I'm if getting the largest order number is just one component of in this logical flow, then I can kind of look at that and be like, okay, I trust that this code is doing what it's doing, right? It's more when you take that big logical flow and again, like make it just 4 lines that are all different calls to different kind of sub functions, where I think the clean code people go a little too far. Yeah, so lots of interesting tidings here, right?
Yep. Yeah, and again, I will say that like I appreciated that the one pile method was right after extract helpers, because it really is its philosophical opposite.
Mhm.
And I agree. I think it's neat to sometimes make these deep functions so you really understand what's being done. And again, you might realize, oh, actually, I'm calling the same logical chunk with a slight variation on it 3 times in this big pile. Well, maybe I should turn this into a helper function, because I bet this is so, some list comprehension abstraction that I'm doing that would be so useful. I'll make a general list comprehension thing with my implementation. I'll simplify it in the code that I have. And then actually, you know what? There's like 3 other places in my code that I could use it this way, right? So that's actually a great example of breaking out, knowing like looking at the big flow and then saying, okay, I'm going to go back. And I think there's a relationship between those two that's helpful. So,
Well,
yeah.
let's take a quick break, and we're going to move into part 2, which is about managing. We're going to talk about how do you fit tidying into your personal development workflow. We'll be back with that and more right after a break. And we are back. Thank you so much for tuning in. Well, let's talk about managing. Again, this is like Nathan pointed out at the beginning of the podcast. This is not tidy first; it's tidy first. There's a question mark there. So we got to figure out, when do we start tidying? When do you stop tidying? How do you fit into your development workflow? A couple interesting things in this chapter. One thing I found really interesting. He talks about, well, where does tidying go, like in a pull request workflow? Do you have your
Right.
own pull requests for just tidyings? Are you doing it in your own work? I thought it was interesting that he kind of trashes pull requests. He says code review processes, which I promised multiple times to trash, but now is not the time, don't distinguish between reversible and irreversible changes. We end up making the same investment with radically different payoff profiles. What a waste. And he says at a lot of places, kind of like there's a fixed, well, at everywhere, right? There's a fixed cost for getting a pull request in, right? There's the cost of, getting your branch, sorting out the merge conflicts with main, getting the pull request up, looking for reviewers, right? Like all of that's going to happen with every single pull request. And then there's the additional costs of changing the code in accordance with the comments left in your pull request. He says basically this fixed cost is not applied evenly to all changes in code, right? And because of that, in some places that fixed cost of submitting a pull request is very high. And so people will try to get all of their work done in as few pull requests as possible. And that makes these tidings a little homeless. He recommends in high trust enough teams to not even have pull requests for tidings, just to trust people to kind of submit it. Like I think it's an interesting idea. I don't know, like obviously that I could see that working if you're like a three-person team at a startup. I don't know how that scales to like a bigger company, but it was an interesting idea.
Right. I had the same thought. I don't know how to. I think there are certain teams that sure, or if there's not that many people in the code base, kind of a thing. My only worry is that there's going to be like incompatible tidying methodologies, and that you
Yeah.
end up having a real big problem where someone's very opinionated, they strong arm their way in, and then all of a sudden they're asking forgiveness and not permission, which I think is very dysfunctional. And so you have to be careful. But that being said, if you had Kent Beck on your team and you knew that he was going to do an awesome job, I could see how certain teams might let their guard down and just go, you know what? Like, he's never screwed this up. He's the TDD guy, so it's not going to break anything.
Yeah.
Yeah. But it is interesting. I thought this was interesting too. It's like, I think you have to have the right team, especially, some people have workflows where they do stacked commits, right? And I think in an environment where stacked commits, where basically the commit queue is deterministically set up by the queue of commits that are out for review. A lot of bigger organizations do this. And I think something like these super tight PRs around tidying would work really well. You get into a synchronization problem where like I know there's this thing I really want to do, but I need to do these 4 tidyings before. He calls it chaining, right? I want to do these 4 tidyings before. And so cognitively, I think it makes sense for these each to get approved individually. He also talks about the fact that maybe, okay, well, maybe these two could be kind of put together, right? But you still are blocked on this. And so if you're getting back to looks good to me, if your code review process is strained by senior development who is only able to do this, 2 or 3 times a week or something, you might take a 1-day turnaround PR event and turn it into something that takes a week and a half because of cognitive load. And you might confuse folks and being like, wait a minute, I asked you to get this feature done and you're just sending me like tidying PRs. Like, why are you doing this? Again, I think it has to do with like the culture of your team. But I've definitely tried this method before, especially when new to a code base. I'm about to sneeze, so we'll see. Maybe I won't. The and it's interesting because sometimes a tidying PR is like a nice safe way of learning the code review process, and something that doesn't fundamentally change the behavior of the software system. So I actually think that
It's kind of related to like scratch refactoring
yeah,
and working effectively with legacy code.
yep. Yeah, exactly. And so I think this one's kind of cool. And he talks about this too, right? He talks about like the rhythm of like, well, what should the cadence be, right? So he says, let's go back to the beginning. You're tidying to make future changes to the behavior of the system easier. You're making future behavior changes easier because they're worth it, right? So there's this idea of like, well, is there a way that I can fit this into my cadence? I keep thinking about like cleaning my office, right? Which is, I've been experimenting with setting aside some time in my day to just do not fix everything because this is propaganda. Like I've said this before, you don't see the messy parts of my office. I'm always doing like stuff, and sometimes I don't finish and put everything back up at the end of the day. So I'm trying to like put a cadence of, oh, okay, well, I'll do this section. I'll put up these types of tools or something. And again, I think this whole section of the book gives you this sort of tools and techniques. I I loved chapter 21. I'd love to hear your thoughts on this. He calls it first, after, later, never. So
Yeah. Well, just before that, just thinking about kind of this idea of like not having PRs for tidings. That's the kind of thing where I might evangelize that if I want to stir stuff up on Twitter. I know there was like kind of like not controversy, but like the hot takes of like serverless is garbage, or why would you ever use the cloud when you can just host your own, blah blah blah, and like it's funny. I read like a lot of like parenting blogs and follow like a lot of parenting Twitter, and I can kind of tell like when these kernels of ideas begin, and I'm like, I think this is going to be big in a couple of years, right? Like,
right.
and I feel that like I just reading this right here, I'm like, give it a few years. I wonder if you'll start seeing an anti-pull request movement, and if Kent Beck has laid the foundation here. But yeah, so then because he talks about like like you said, chapter 21, first, after, later, never, like, and that's the whole question. Tidy first, and the answer is it depends. So he's got kind of these questions like the first, after, later, and never, or these categories. So when he says tidy never when, you're never changing this code again, and there's nothing to learn by improving the design.
Right.
That makes sense to me, right? And I think that's when you have to think about the utility of software engineering, right? And that this isn't like some avant-garde art piece. This is we're making real products that fulfill a real business need, because you can kind of get into that mindset of like, oh, I found this old decrepit class and look how gross it is, and I'm going to show how good a craftsman I am by tidying it up. And it's like, well, do we need to learn anything about this part of the design? I think he says here, like, this is a little case of like, if it ain't broke, don't fix it. And we might never need to touch it again. So you probably don't want to tidy here.
Right. And you also have to remember that anytime you touch part of a system, you could have unintended side effects, right? Like that you may not understand as well as you think you do, and you could cause harm, right? I mean, that's
Absolutely.
a legitimate concern.
He says, tidy later. When you have a big batch of tidying to do without immediate payoff, there's eventually payoff for completing the tidying, and you can tidy in little batches. So here we can see him connecting to the idea of payoff and how immediate it is.
Right.
And I think part of the whole tidy later idea is later is perpetually later, and
Mm-hmm.
you might never get around to the tidying because there's not the immediate payoff. Maybe there's a slow season in work, and so you say, oh, all that tidying I've been thinking of doing that would be useful eventually, maybe now's the time to get into it. But you don't tidy if there's not an immediate payoff. It says tidy after, when waiting until next time to tidy first will be more expensive, and you won't feel a sense of completion if you don't tidy after. He talks about this a couple times in the book, that our feelings as a programmer matter, and that don't underestimate how much better work is when it feels fun or when you feel good about yourself.
Right.
So I thought it's interesting that he lists that as our criteria here. If you won't get a sense of completion if you don't tidy after, maybe you should tidy after.
Yeah, and I like the distinction between later and after. After literally means you've written the implementation, it works, but you're going to tidy up before you actually like ship this thing, right? Before you know that your tasks are done in the Scrum board or whatever, right? That you have. And I think it's a cool way to give yourself permission of being like, you know what, let me just get through this implementation, then I'll clean it up, right? The later, it reminds me of like there's the old getting things done methodology. They would say you'd put that on your someday maybe list, which is that like I haven't written it off as I'll never do it, right? But I don't know when I'm going to get to it, right? And so I think there's a nuanced difference between later, which may never come, and after, which is I don't consider it complete unless I've actually done the tidying tests.
Yeah, I think that's a great distinction. And then we come to tidy first. He says, when you tidy first, it will pay off immediately, either in improved comprehension or in cheaper behavior changes, or you know what to tidy and how. So this is a scenario where you might come into a big code base. It might be complicated and hard to read, and you get that immediate payoff and say, you know what, if I just rearrange things, tidy up a bit here, then it'll be easier to actually reason about the changes I need to make. So I think, he connects it all to this idea of like payoff. Is the payoff going to be immediate? Then tidy first. As that payoff becomes more and more delayed to the possibility of never paying off, that changes when you should tidy. And I think it's great to think of that way as a developer, to think in terms of that payoff, because again, this is where the term like best practices gets abused, right? Because you say, well, tidying, it's just a best practice. But what does that mean exactly? We need to be thinking about in terms of payoff. And that'll give you a good idea of when to tidy.
Yep. So this is actually a good transition into the third and final section. He's talking about managing all this stuff, but even that last little section of like never, later, after, first, that really starts getting into theory, right? And this philosophy of how do I make these assessments? How do I validate whether something should be tidy first or should be tidy later? And this one, we're plowing through this book. It's a pretty quick read. And then you start getting to like chapter 24 through the end, and you're like, oh, this is cool. Especially because like he had some time when he was, from what I remember in the book, he was first developing TDD, right? So he was one of the first, I think he coined the phrase test-driven development. This is back during the extreme programming days. And he was doing like trading algorithms and trading software and it like bled into his life. And then you can see why this was such a big deal, because all these concepts around like options trading and all these things that he was doing TDD on, right? He needed like a test subject on how do I do TDD based software development. Obviously this had a huge impact because the rest of this book is on these like kind of cross-functional or to interdisciplinary worldviews that absolutely work in commodities trading and stocks and all these other things, and are actually like really good advice in general. Like you could apply these to all parts of your life. Should I do this now or should I do this later? Is this actually valuable? And I don't know. I think we both got really excited about this section of the book.
I was a little annoyed at the structure of this book just because it was kind of like in one of my classes I'm working through right now. It's very project based, and it's and so like I did project 1 and project 2, and they both took me like 5 hours each. And so I was like, okay, I've got a good idea of how long the project in this class take now. I get to project 3, it was way more complicated. I kind of put it off longer than I should have because I thought it would take 5 hours and it wound up taking like 20. And so that was I kind of feel that way about this book is like I put this off until last night to finish reading just because I've been busy with so much other stuff. But I'd read the first half and I was like, okay, I get this book. Like I read Refactoring. I read Looks Good to Me. A lot of this makes sense. Tomorrow night, I'll just kind of breeze through part 3 and, we're covering a lot of the same ground. Then part 3 comes out and it's like some of the most fascinating stuff I've ever read. And I was so mad because I'm just trying to like read it as fast as I can because I had other stuff that, that I had to do. And I just finished reading this book like 8 hours ago. So I wish I could have soaked this stuff in more. I might go back and reread just this section because I thought it was so fascinating. But yeah, talking a lot about like economics talks about the time value of money, which we understand to mean, right? If you've taken any like basic finance class, right, $1 today is worth more than $1 tomorrow, right? Because that dollar today I can invest, and really what that dollar provides is it provides optionality. It says, in a chaotic situation, options are better than things. So create options in the face of uncertainty. It says, in the scope of this book, the time value of money encourages tidy after over tidy first. If we can implement a behavior change that makes us money now and tidy after, we make money sooner and spend money later. As noted earlier, sometimes tidying first means the total cost of tidying first plus behavior changes is less than the cost of behavior change without tidying. Always tidy first in such a case. Yeah, I thought this was just a really interesting concept of like building optionality into, he talked about it in like a business sense that you kind of want to be open and available to taking different paths and to pivoting and to having new strategies when designing software, because that, he says, that optionality is what makes startups so dangerous, because as a company gets bigger and bigger, they lose that optionality. They become more set in their ways. A startup can pivot to be doing potentially entirely new things. And he kind of associates that with like building your code too, that you want to design your code in such a way where it has optionality, where it can pivot to be something different if you need it to be.
The optionality is a big deal because I think this is one of those areas where you need to think about this idea of like what's reversible versus what's not reversible. This idea of do I have options for the future? I loved that framing of like $1 today is worth more than $1 tomorrow, and that optionality gives you like an out of chaotic situations you couldn't have predicted, right? So that's the whole point of like options trading, is that like, hey, if things are going on the track that I want, I'll pay a little bit of a premium over the market value, but I also get the option to like back out of my commitment, right? Like I'm going to buy I want to buy bananas for $1 a banana or whatever, but I'm not sure that I actually need bananas in a week, so I'll pay an extra 3 cents for the option to buy bananas at $1. But if I don't need bananas, I'll just eat the 3 cents, right? Like that's the kind of idea behind it. And so you putting this into software, you're like, oh yeah, well, I'll take on a little bit of cognitive load of doing a little tidying up front. That's the 3 cents I'm paying. Because I might need an out in a week because, oh, you know what? Once I show this to the CEO, he might change his mind. Like he might be like, oh yeah, that's actually not the problem we're trying to solve. And so can I write this in a way that it's adaptable to what I think could shift, right? And you just can apply it to all kinds of stuff where you're as a team, or I've been very explicitly asked for this explicit implementation. But right now, it would basically be hard coding that into the flow. And I think that this is the abstract layer of like, we might want to hot swap these implementations. So we'll only have one. It's going to be the reference implementation, but I'm going to give it a little bit of a wrapper so that if I need to like do inversion of control and swap out this thing, like you can see where you're like, okay, well, tidying up makes sense. I will, break out the hashing algorithm because right now they've asked me to do SHA-256, but I think that Blake 3 is going to come up. So I'll make sure that it's easy to swap out later if I need to. It takes me an extra 15 minutes to abstract that out a little bit, and then boom. Like, this is the section where you're like, okay, it is worth it to do this, right? Or it's a nice to have. No, we'll never go off SHA-256 because that's what Git uses, and Git's never going to move off of that, at least not in the next 10 years. So it doesn't make sense for me to abstract it because this is a 10 years from now problem, and I'll deal with it at that point, right?
Yeah, it's interesting, this idea. You talk about optionality, talks about building things in a reversible way. We've talked about that before. The difference, Amazon calls them one-way doors versus two-way doors, right? Two-way doors, you can just go back out the other way. One-way doors, shut, you're in the room, until you exit through another door. And he kind of talks about like the value, like it's more important to embrace optionality and making things reversible than it is to be smart. And how does he frame it? He says, there seems to be an idealistic form of geek thinking that holds that if only we made better decisions, we would never make mistakes. I was a young adherent or worshiper at the altar, if only I were smarter. Or if only I were infinitely
smarter.
Yeah, if only I were infinitely smart. Yeah. Fortunately, I got over it. I learned the value of reversibility long before I had a name for it, and realized the value of making decisions reversible, which I love this idea.
Yeah.
We're never going to be infinitely smart. We're always going to make mistakes. I'm such a big fan of just confronting the realities of how we live. Like, I think I've said this before, but like, I hate when my kids lose their shoes. Guess what? Toddler shoes cost we get ours from Walmart. They're like $12, right? Why on earth am I not just buying? And that's what we started doing. I just buy multiple pairs of shoes every time our kids, go. And because like for me, again, I know not everyone has an extra $12 to spend, but I am a professional software engineer speaking to an audience of professional software engineers. We're compensated fairly well. And so that's money well spent to me, because I hate when the kids lose their shoes. And for me, we always find them, right? It's not like we're just buying disposable shoes and throwing them out, but it just means that we're never stuck in like the crap. We have to go, we're running late, but where are the shoes? They say, well, we'll just bust out the backup pair in the closet.
Well, and the cost to disruption of your flow for the family is probably more than $12, right? Like
that's what I think.
Yeah.
I made my son the other day. I was so mad at him. He gets grouchy when he doesn't eat. I don't care if he's hungry. He can be hungry. Why is it my problem? He gets so mad at me. And so like he had specifically asked for peanut butter toast. And I'm like, okay, I'll make you some peanut butter toast, but you got to eat it. And I found out later that he threw it away, which I didn't mind as much, but it made my wife really mad. And so when my wife gets mad, I get mad too, because I did not like that he was disrespecting my wife. And so I told him, we've just started giving him an allowance, and I computed my hourly wage, and I told him, like, okay, it cost me 5 minutes. It took me 5 minutes to make this sandwich or to make this peanut butter toast. And so I just told him, I said, the next time you throw it away, you owe me. And it was like, it was, I did my hourly wage and then plus the cost of ingredients. Like, you owe me that much money the next time you throw it away. And I said, like, if you don't have to eat it, just don't ask me to make you it and then throw it away. And he was like, oh, wow. So yeah, you were just talking about like the cost of our family time. Like, oh, I actually, illustrated that very plainly for my son the other day.
It's quantifiable. And I think, even with these really basic algorithms that he gives, that's a good example of that, where you're like, and there's also like, there's also the emotional cost, or the just like, well, you're ready to go to this thing and you can't find the shoes. And now you're kind of annoyed. And do you really want to be annoyed for the whole trip that you're taking? Is that worth $12, right? Like those are another pieces. So I loved the framing about the one-way versus two-way doors. And he goes, what's the difference between a bad haircut and a bad tattoo? The bad haircut grows out, but the tattoo is forever. Well, not forever, but way harder to undo. And I think that's a great example, right? You're like, am I making a tattoo decision right now or a haircut decision? You're like, am I freaking out and being like, oh, like, do I want bangs versus like having my hair long? Well, if it was a bad idea and you cut the bangs too short, no big deal. Like, you might be embarrassed for a little bit. You might have to wait for it to grow out. Not a big deal. But yeah, tattoo, like, do I want to get, Dwayne The Rock Johnson full like face on my back? Like, maybe you should think really hard about that before you do it, right? And so yeah, I loved that that idea of like reversible structures, because I think cognitive load wise, you can in a blink of an eye make a decision that's very bad, right? And it's not like making a silly reversible decision is harder to do than an irreversible one. But I think really understanding like, wait a minute, do I really want this tattoo? Like, is this really necessary? Do I want to spend the money on it? Will my future self be thankful that I got this thing? Probably not. So yeah.
When I was a missionary for my church in California, we you have a mission companion, and you're supposed to stick together all the time. And so when we got haircuts, I had a companion. He was Hispanic, and his hair was just it was different from mine. So we went to like a black barber shop, which is great. They provide a valuable service. That was when I found out that they're not used to cutting white people's hair as much, and I just was like, yeah, because I was just saying, like, I want a little longer in the front to put it up, and I don't know if he didn't listen to me or whatever. Very first thing he does is take the razor and just go bzz, like right up the front, and I was just like, and so I was so mad, and I tried to have him fix it, and it wound up just looking terrible. I should have just gone all in and buzzed it, but it's like such a
full bald.
I honestly, right? But like as a missionary, you're out and about every day. It was so public, and so just reading about like this bad haircut, I'm like, oh, I remember that bad haircut. But thankfully, it wasn't a bad tattoo, right?
Yes, exactly. You didn't get a face tattoo.
Yeah, exactly, right. Just an embarrassing couple of weeks. Yeah, he talks about coupling too. Coupling, we've talked a lot about in this podcast, is one of the prime evils in software, right? He says, well, what does coupling mean for answering the question, should I tidy first? Sometimes when you're staring at a messy change, it's coupling that's harshing your mellow. He's very hip with the times. But if I change this, then I'll have to change all those too. Messy. Take a minute to go through the list of tidings and see which of them would reduce coupling. And I think he summarized very succinctly, coupling drives the cost of software. Yeah. This is one of the big theories of John Ousterhout's book, A Philosophy of Software Design, which is that complexity is the primary driver of cost in software, and that coupling is a huge form of complexity.
Right. And I think to put this into framing, he has this thing called Constantine's equivalence, which is roughly that the cost of software is roughly equivalent to the cost of change. Meaning, so if you can reduce the cost of change, it reduces the cost of software, right? And I think that's a really, it seems very simplistic. When I first read it, I was like, why are you even writing about this? And I was like, it's absolutely true. Like we talk about this a lot at work currently. It's like research-driven software development, reducing the cost of experimentation, right? Reducing the cost of making it so that I can propose a change, update the code, do all these other things. And because our stuff's open source, we actually have like very high code quality. But we had a big debate internally about some refactoring or pulling out some. It wasn't refactoring. It was actually like a pretty big change of like taking a command line tool that had a bunch of subcommands and maybe removing some of the subcommands that shouldn't be there, and should they be their own command line tools. Big debate on coupling, actually. It ended up that we ripped out a few of the pieces because they were almost used by no one, but except for a couple of like internal folks. And because our code's so well structured, what I thought was going to be like, and I was just an observer, I'm new to this company. What I thought was going to be this big deal was like, it was a pretty big code change. It like touched like 35 files. But a lot of it was because we had connaissance of naming was actually pretty straightforward. And some of it was like restructuring packages and changing names of functions, all these other things. None of the tests broke. Everything was really cool. And it was one of these things where you're like, in some companies, this would have been an impossible change because of how they structured their code. And here, the cost of the change ended up being very low. And so there was so like, I think where some folks who were a little worried about how this was going to happen, it was a beautiful example of like, oh, this is a lot of tidying has been happening along the way. And Constantine's equivalence actually paid off really well.
Absolutely. Well, I think, we could spend hours talking about this book, but I think we've covered a lot of the main topics. Is there anything you want to talk about before we kind of give our final thoughts on the book, Nathan?
No, I think the wrap up would be a perfect segue to this book. I mean, again, if you get the audiobook, it's just like a 2.5 hour, it's under 3 hours of audiobook.
Yeah.
So, I mean, we basically covered a third of it just from time standpoint. So, enjoy.
I love, you ever see, I love the YouTuber Jenny Nicholson. She does like, she reviews like movies and does like a lot of like theme park stuff, and I love theme park stuff. She just did like this 4-hour review talking about, I think it's called The Spectacular Failure of the Disney Star Wars Hotel, and it's excellent. It's like a documentary practically. But she like reviewed the Joker movie and didn't like it that much. But then there's like this 8-hour response. Someone made like an 8-hour response video of like responding to Jenny Nicholson's review about the Joker. And someone's like, the Joker movie's only like 2 hours. How do you get 8 hours? And so we've kind of, not exactly that, but this is a 2.5, 3-hour audiobook, which we've recorded a 90-minute podcast about. So,
and the director of Joker was just mad. They're sad that the trampoline got taken away.
Yeah. Yeah. That's death of the author, folks. And the death of the author here, Kent Beck. Well, we're going to spend, this is a tidy first podcast now. We're going to do 10 hours of content on just this book. No, it's great. But here, this podcast is free, whereas you got to pay for Tidy First. But you should pay for Tidy First because we really enjoyed this book. I think as far as what I learned from this book, and I'm going to try to do differently in my career, sometimes we come away with this with much more specific ideas of what exactly we're going to implement in this career. For me, I just want to kind of think about more optionality in my work. I liked that idea of, and not even just optionality in the code I write, but even the plans we're making, that just as you kind of preserve that optionality, there's a lot of value in that. And so I don't know if that's something that is going to change a lot at the company I work at right now, just because it's a big company. And so, our marching orders are fairly set, but ultimately I'd love to either work at a smaller place or have my own place. And I think this is a good lesson for me to learn. I want to remember this as I go throughout my work. Yeah.
For me, it's the framing things in terms of investments, right? Like I actually really resonate with me in the same, it's kind of abstract, but I do want to do this idea of like, should I do it, before, after, later, or never?
Yeah.
And then quantifying that in the sense of like, is this going to help speed up? Is this going to be a better return on investment for myself or for the company? And so I'm going to try to take a step back when I'm at a decision point. And yeah, is it a haircut or a tattoo, right?
Yeah. So, well, and that payoff idea, right, of like how immediate is the payoff? I'm actually working on this feature at work right now where like we know it's going to be deprecated in about 18 months, but it's going to provide a lot of value in those 18 months, and it's taking me about 2 weeks to get off the ground, right? And so we've kind of made that decision like, hey, it's going to be a pretty immediate payoff. It's not going to last forever, but it's pretty quick. So I think,
it's got to be like maintainable enough, but doesn't have to be, 10 years of maintenance. Yeah,
exactly. Well, who would you recommend this book to, Nathan?
Yeah, so I think that I'm adding this to my list of general recommendations, and specifically before reading Refactoring. So I think that this would be a great graduation gift to a student. It's very short. The odds of you getting through it and getting high payout are very high. So I think that's kind of hits a bunch of things. Easy to recommend. And I think you could because of the way it's structured with concrete examples and then getting abstract, I think someone earlier in their career would get a lot out of it immediately. But I don't know, software engineers in general, it kind of our audience. I think this would be a general recommendation for our audience.
Yeah, this book is great if you want a quick read. Like this book packs a punch for 125 pages, right? Because as I was reading through it, I'm reading through part 1, which is about like all the different tidings. I'm like, well, refactoring, cover this more in depth, right? And so does this feel like a watered down version of refactoring? And then you get to part 2, which is about managing. And I thought, well, looks good to me. Kind of talked about a lot of these concepts, but in greater depth. So for me, it felt like kind of retreading common ground. But not everyone wants to spend 300 pages of reading on those sections. So this is great if you're looking for a short read. And it's particularly great, part 3, the theory, and just talking about, like, we weren't even able to do it justice. But yeah, it's just really interesting for him to kind of bring it all back down to earth. And I feel like I don't see a lot of as much candid discussion of like, this is how software makes money. And this is how software is directly related to money. Really, really fascinating stuff. And so anyone who's kind of like interested in like the philosophy of how software makes money and how do you build software to make sure it has the greatest chance of making money, that last part is really, really interesting. So anyone who's curious about that kind of stuff, I'd really check it out.
Yeah. That actually, that as a final thought piece, I think that this is the crux of the difference between the TDD world and the John Ousterhout world, which is that, John is working on a domain of problems in which the code will live in perpetuity inside the Linux kernel or as a programming language for a very long time. And that's a different type of software development as versus somebody who's like, my company needs to make money now with their understanding of the world that we have now, and things are going to change. And I think that if you're building the type of software that John Ousterhout's building, like operating systems, device drivers, programming languages, you really do need philosophy of software design, and you really do need his methodology. But if you're building something for a business and things are changing and things are super volatile, I've come around to being like, these are both correct given the constraints of how you need to build software. And so I got a much deeper appreciation listening to Kent, Beck, like his perspective. So he actually, this is one of the things that also I appreciate about Kent Beck is he also tells us who this book's for. And so I wanted to put this at the very end, which is audience. This book is meant for programmers, lead developers, hands-on software architects, technical managers. It's not tied to any programming language, and all the developers will be able to read and apply the concepts in this book to their own projects. This book assumes that the reader is not new to programming in general. And as a great description of who this book's for. I completely agree.
I love, it assumes that they're not new to programming in general. I think all the books we've read have done that. It's made me think, like, what if we just read like an intro to Python book? Like, that'd be pretty funny. Like, dude, you ever...
A list is...
Oh, yeah. Well, you're in a dictionary, man? This is crazy.
Though I will say, I do remember when I first learned those things, and it blew my mind. Like, there's basic data structures, and you're like, oh, I could just iterate over a list, or I can find something in here, or, oh, there's dictionaries are the coolest thing ever, all these things that I remember that excitement. I mean, I'm not excited about it anymore, but there was a time in which I was like, this is why people program. This is cool.
My wife is working through her degree, and she's doing a data structures class right now. Like, my wife is smart. She's smarter than me. And it's been interesting watching her struggle with these things that are just so like second nature to me. And then to remember, like, oh, I struggle with this stuff too.
Yeah.
And that and being blown away at the beginning, you realize that this is a discipline, like, it is a weird discipline we have. It's very abstract. We deal with stuff that people can't wrap their head around. Like, and why should they be able to, right? This is a niche field in some ways. But it's not like if you tell someone like, well, what do you do? It's like, oh, I'm a chef. And it's like, well, I don't know how to be a chef, right? But I can visualize someone cooking in a kitchen and chopping things up and frying things in a frying pan, right? You forget that this job, if you tell someone like, I'm a software engineer, they don't even know what that means, right?
Oh yeah, no, it is fascinating. And so again, I think that these types of book in our craft and like listening to folks who've been doing, software's eating the world. And I think as we grow this podcast and we branch out into the types of books that we have on the horizon, it gives us a glimpse into whole career paths that even with the same job title, right? Staff software engineer or software architect, it's radically different if you're in, fintech versus medical versus banking versus, some startup that's building a mobile app. And all of those folks become domain experts in certain types of problem solving. And, there's an endless amount of empathy that we can get. And, building on these building blocks, these more abstract things, I think it's going to be cool to see, how folks who've been successful in their field have decided to sit down and write a book about why they deeply care about some topic. And that's what I'm super excited. This book kind of opened up, I think the philosophy made me like very philosophical about a lot of things. Cause I'm like, yeah, how does this apply to all these things in life?
Well, it was a great book. We recommend you check it out. Tidy First by Kent Beck. We really enjoyed it, and we're really enjoying making this podcast. Thanks so much for tuning in. We feel like we have a little more permission to get to wax philosophical at the end of the podcast rather than the beginning. Because if you stuck around to the end, then you just like listening to the sound of our voice. And as always, thanks for tuning in. You can contact us at contact@bookoverflow.io, Twitter @bookoverflowpod. The Twitter account's been a little silent for a bit. I disabled the Lambda that was sending out tweets. I got to get that back up and running. Just been busy lately. You can find me on Twitter @CarterMorgan. You can find Nathan and all his work with Functionally Imperative, where he interviews fascinating creative folk at www.functionallyimperative.com. And please get in contact with us. We love hearing from you guys. We get emails from you guys, and it's always great to know that you're appreciating the podcast. We're excited how it's growing. I think we just hit 4,500 subscribers on YouTube, and we have another 3,000 or so across audio platforms. And so it's good. We're having a lot of fun making it, and we like that you guys are enjoying it. And so please keep tuning in. We've got lots of great books to come, and we will finally get to Software Engineer's Guidebook next week. Very, very excited to tackle that one. I love George Leora's. I'm a big fan of Pragmatic Engineering, his newsletter, and I follow him on Twitter. Really, really great guy, and so I'm excited to dig more into his work. And we hope you're excited for those episodes.
Awesome.
We'll see you around, folks.